So I'll be doing number 37, and it says the car starts from rest and travels for 5 seconds with a uniform acceleration of positive 1.5 meters per second squared. The driver then applies the brakes, and this signals a two-part question. And this causes a uniform acceleration of negative 2 meters per second squared. If the brakes are applied for 3 seconds, that's the time, how fast is the car going at the end of the braking period, and how far has the car gone? So first, a diagram needs to be drawn. So we have your car at an initial velocity of 0 going in the positive direction. So we need to first label the givens, which is the initial velocity is 0 meters per second, the time is 5 seconds, and the acceleration is positive 1.5 meters per second squared. And this information is for the car before it hits the brakes. So we need to find the final velocity of this period in order to use the final velocity as the initial velocity for the brake. Because at the end of this period, the speed at which the car is driving at will be the speed at which the car starts pressing the brake. So we use the first equation, and we to find the final velocity, and we plug the numbers in. So we get 0 meters per second plus 1.5 meters per second squared times 5 seconds, and the square becomes 1, the exponent becomes 1, and this one crosses out to get 7.5 meters per second. Then, since this is a two-step question, we need to do this equation again. So we plug this in, but now it's the initial velocity plus the negative acceleration because we are applying the brakes times the period, which is 3 seconds, to get a final velocity of 1.5 meters per second. Now the second part asks, how far has the car gone? So now how far signals position. What is the change in position? So we use the change in x because it already gives us the initial, the time, the acceleration, and the time, as said. So the first step is to see what you're looking for, and as said, it's the displacement. So the displacement, we use this formula, which is 0 meters per second times 5 seconds plus 1/2 times 1.5 meters per second over second squared times 5 seconds squared. Now this is talking about the beginning, because how far the car has gone includes the time when it was accelerating in a positive, when the acceleration was positive. So for this part, we get 18.75 meters. And now we need to solve how far the car went when it was applying the brakes. So the change in x would be, you plug the numbers in for this section into this equation to get 13.50 meters. Now this is how far the car went accelerating, and this is how far the car went after it applied the brakes. So to find the total, to find the change in position for the total amount of time the car was moving, we add these two up to get 32.25 meters. So this and this is your final answer.